Okay, so hello everyone. My name is Ruchita Sardis Minerval, and for today I will be sharing with you or discussing with you how to implement stock using linked list. But before we do that, let us know first the basic operations on stock. Okay, so before we proceed knowing the basic operation in stock, I would like to explain first of why we should know this operations first. So we should know these operations first because these operations will be used in manipulating our stock. Okay, these are very useful in implementing our stock using linked list and even in arrays. That is why it is important for us to know these operations. Okay, later on I will further discuss about why they are important. So now let us know first the basic operations in stock. So first is the push. So push method is used to insert an element into the stock. So it is used to insert or add element into the stock or into our linked list. Okay, push. Next is the pop. So the pop method is used to remove an element from the stock or to delete an element from the stock. If the push is used to add or insert element from to the stock, our pop method is used to delete element from the stock. So next, the top method. So the top method returns the top element of the stock. When we say top, like the last element of our stock. Okay, so that is the use of our top method. If we wanted to get our top element of our stock or of our stock node, then we will have to use our top method. Next is the isEmpty. So the isEmpty is obviously a method that is in Boolean data type. Why? It is very obvious in its name, isEmpty. It returns true or false, because Boolean, again, if you guys don't know, Boolean accepts only two values, which are true or false, and the isEmpty is answerable by true or false. So this returns true if the stock is empty, false if the stock is not empty. So next is the size. So the size method returns the size of stock, or let's say the capacity or length of our stock. So next, okay, so before we talk about the time complexity, again, it is important for us to know those basic operations because those are used in manipulating our stock. Okay, are manipulating our stock in linked list or in array, right? For us to be able to add, we need the push. For us to be able to delete, we need the pop. For us to be able to get the last or the top element of our stock, we will have to use the top method. For us to be able to know if our stock is empty, we will need the isEmpty method. If we want to know the size of our let's say stock, we will need to use the method size, right? They are very useful. That is why I would like to introduce them first to you, because they will need to be deployed in our program so that our program will function well. Diba? For us to be able to know what to deploy, what are the operations to deploy, so that we can successfully aim what goal we want in implementing our stock in either using array or let's say linked list. We will need to know those operations. Okay, so next is the time complexity. I would like to add this because those operations I have mentioned, those methods that I have mentioned, has a time complexity of big O of 1. It's the it is the least time right complex in our, let's say, chart. Okay, so those methods that I have mentioned has big O of 1 time complexity. So meaning to say those doesn't consume that much of time. So another is when we are adding or we are inserting and deleting at the front, we are adding at the front or at the beginning of our stock, its time complexity is big of 1. But when we are deleting from the top or from the last of our stock, its time complexity is big O of n. So what is much more advantageous, the big O of 1 or big O of n? They have not that much of they don't have that much of difference actually, because they are just, let's say, sunod ra ang big O of 1 o big O of n. However, it is much more advantageous if our operations or the operations that we use has a big O of 1 time complexity. I just added it so that you guys know. So next is what else? Now let us know how to implement our stock using linked list. Okay, let us implement stock using linked list. We have already been discussing how can we actually implement stock using arrays. It is much easier than implementing stock using linked list. However, linked list is still great to use because it is good for, let's say, if we don't know in advance the length or the size of our stock. Okay, there is a reason of why there are two ways of implementing stock. So now let us proceed in implementing stock using linked list. So first, we declare the public class stock as linked list, meaning to say, since it has an access modifier of public, so meaning to say our class stock as linked list is it is our main class. Okay, in our program, it is the main class of our program, and we named it stock as linked list because we will be implementing stock using linked list. Okay, not array. Okay, we wanted our names to be very it has purpose, or let's say meaningful, right? So next is we declared stock node root, like the top. Okay, root is similar with top. Okay, we created a stock node top or root. So when we say stock node, right, if you wonder, stock node, let us consider every element. Let us consider every element as let's say, let us consider every element as node. So when we say node, it has two fields, right? So the one is the data, and the other one is the, let's say, the pointer, right? So that those are the two fields of our node. So that is stock node. Let us consider every element as a node, and a node has two fields, which includes data and a pointer. Okay, so that's it. So next is we created a static class stock node. Okay, we created a class stock node with non-access modifier static. So that non-access modifier static indicates that our class static node, a stock node rather, is it belongs to our public class stock as linked list. Okay, that indicates that our stock node class belongs to our stock as linked list. Okay, meaning to say we actually no longer have to create we no longer have to create let's say we no longer have to create an object for us to be able to access this class because it is already static. However, we will still need an object or an instance of a class because we will be creating a constructor later on. I will show that to you. So next is the int data. Okay, int data. So we declared a variable data in integer type. So obviously we will store a value in data variable and in integer type kind of value, a type of value rather. So next is we created a stock node next. Okay, if we have an attribute of our stock as linked list stock node Ruth, this time in our stock node static class we have an attribute of stock node next. So it is a pointer. Next is we created a constructor. When we say constructor, it is a special method. Okay, it is a special method that is used to initialize objects or attributes, right? So in our stock node special method, we initialized this attribute of our stock node class in value data. Okay, so we accessed our variable data, or let's say our attribute data of our stock node using this keyword. Okay, so we use this keyword to access objects, right? Okay, so since data is an object and it belongs to stock node class, we use this keyword and we specify or initialize its value to data, which is our parameter of stock node. Okay, so let's erase so that it will be clear for you. Okay, so that. So this is the object or attribute that we accessed, and this is this parameter data is the initial value we specified to our object or attribute data that we accessed, right? Is that understandable? So next is we will be defining our methods or functions, and the methods or functions that we defined will be used in our main method later on. Okay, these methods that we defined or we declared will perform a certain operation later on once we invoke or call them, right? So in the main method is where we declare or put codes that are to be executed, right? So of course, in our functions that we defined, that includes the basic operations that we have, that I have rather explained or discussed to you earlier. The basic operations, including the push, pop, top, and the is empty, right? So expect to see those here. Okay, excuse me. So our first method that we defined is the public boolean is empty. I have mentioned earlier that obviously our is empty, okay, will is answerable by true or false. Is empty, true or false, right? That is why our data type or primitive type is boolean, because our boolean primitive type or data type accepts its valid values are true or false. So we also put an access modifier public so that we're able to access this method in let's say in any classes. Okay, in any classes that we create, this method will be accessed, will be able to use. So in our isEmpty method, first we have a condition: if the root is equal to null, return true. That means if root is empty, return true, right? As I've said, isEmpty will return true if the stock is empty. False if it is not empty, or else return false. Next is the public void push. Okay, the public void push. Okay, so push again is a method it is used to add or insert element to our stock, right? So it has a parameter in data, meaning to say this data will accept a value, okay, and that value will be pushed to our stock. Okay, so it is in void data type, and its access modifier is also public, so that we'll be able to use it in any classes, in all classes. Okay, so in our push method, we create an instance of our class stock node. Okay, we created an instance of our class stock node. Okay, instantiation. Okay, instantiation. So this is our object, new node. This will be used for us to be able to access the methods, the attributes that's in our stock node class. Okay, so that is our object. So in our push method, first we will check if the root is empty. True if statement. If root is equal to null, or if the root is empty, root is equal to new node. Our root will be the new node, right? If the root is empty. Else, if the root is not equal to null, or it is not empty, we will create a stock node temp, which is a pointer. Because in linked list, since it is a linked list, we will have to do a traversal. Okay, when we say traversal, for us to be able to access elements of our stock, right, of our linked list, we'll have to traverse from head to the last node. Okay, so our temp is our root, but it will point to our root. So it will point to our root, and then our root will point to our new node, and then the new node that next is equal to temp, right? So that creates a new node. Okay, this block of code creates a new node. And then outside the if else statement, outside the condition, we print data push to stock. Whatever argument we put in here, okay, whatever value, whatever argument, that will be printed, okay, through this statement. Okay, for example, our value here is 1, our argument is 1, so it will print 1 push to stock. Okay, push to stock, that will be printed on the console. Okay, so that would be all for the push method. Now let us proceed to the public int pop. Okay, let's proceed to our pop method. Okay, so since our data type is int, we will have to return an integer, okay, to our method pop. So in our pop method, our pop method, we created a variable popped, okay, in integer type. We need to say we will store a value in this in integer type. So in our pop, we stored integer that minimum value. Okay, so integer is a class, and that, you know, integer that minimum value is a constant. It is a constant holding the minimum value. Okay, it is holding the minimum value an int can have. So its minimum value is negative 2 to the power of 30. If we are not going to use in our program, let's say the overflow and the underflow, so we'll just use this integer that min value. If our stock is empty, it will just return this integer minimum value negative 2 to the power of 30. Okay, so that you know of why do we have to encounter this. Okay, whenever our stock is empty, this will be returned. Okay, so if root is equal to null, or let's say yes, if root is equal to null, print stock is empty. Okay, else popped equals root.data. Okay, okay, wait, if again, let's go back. This statement checks if the root is empty or is null. If it is empty, then it will print stock is empty and will return popped. Okay, it will return negative 2 to the power of 30, which is the minimum value that an integer can have. Okay, else if the root is not empty, right, if it is not empty, then the block of code of our else will be the one na ma-execute. Okay, so our pop variable, okay, ma-storean siya. We will be storing the data of our root in our popped variable. Okay, so what is the data of our root? Okay, the data of our root, the one that we pushed, right, must store sa popped. It will be stored in our popped, and then our root will already be the next of the root. So since our root is now stored in the popped variable, the next node, or the next of the root will already be the one that is the root. Okay, mao siya ma-root na in Bisaya. Okay, so then return popped. Okay, return popped. So the data that we stored, or the one that we wanted to the one that we deleted, which is the top or the root, because when we delete, right, it's from the top, right? So it will be returned to our function pop. Okay, the data that we, or the value that we deleted, which is the top or the root. So next is the peek method. If you wonder, we haven't mentioned, or I haven't mentioned about peek. Actually, peek is just another term for top. Okay, the top method that I have mentioned in our basic operation. So meaning to say, our peek method will return the top value of our stock, right? It will return the top value of our stock, which is peek method. Okay, so it's an integer type, of course, because it will return integer. Okay, because what we're pushing are integers, of course. Okay, the values or the elements of our stock are all integers. That is why. So meaning to say, our top is an integer. So in our peek method, we will check first if the root is empty. We keep checking if the root is empty. Of course, we'll have to check every time if the root is empty, or if the stock is empty. If the root is empty, or if that root is equal to null, we will print stock is empty, and then it will return the integer dot minimum value. As I've said, we don't have the underflow, right? We won't be using that here. We will use the integer dot minimum value. We will just return the negative 2 to the power of 30 as an indication that our stock is empty. Else, if the root is not empty, okay, it will return root.data, the data of the root or the top. Okay, the peek, whatever data of our top or peek, which is called root, it will be returned to our function peek. Okay, so now let us move on to our main method. Okay, it's time for us to move on to our main method, where we place our codes that are to be executed, where our compiler reads first, right? So in our public static main, or in our main method, we created an instance of a class stock as linked list. Okay, we created an instance of a class stock as linked list. Okay, so where is that? This is our class. So we created an instance of this class, which is SLL. Okay, object SLL. So that will be used for us to be able to access the members, the attributes, the functions that is under, or that belongs to our stock as linked list. Okay, so now in our main method, we will be invoking the methods that we have defined earlier, right? So first, we invoked the push. Okay, SLL.push with an argument of 10, meaning to say we will be pushing 10 to our stock. right? We will be pushing 10 to our stock. So our stock. So now we will go to our push so that we'll be able to know how will our push add, how will our push add a 10 to the stock, our stock. Okay, so we have here the push method with the parameter data. So we created an instance of a class stack node with new node. Then we check first if the root is equal to null. Since root is equal to null, or the root is empty because we haven't pushed yet any element or data to our stock, our root will be the new node. Okay, so we have a root of 10, okay, in our stock, like this. In our stock we already have a 10, and then it will be printed. Okay, the data, which is 10, will be printed through this statement, diba? So 10 push to stock will be printed on the console or on the screen. Okay, that is the first statement that will be printed on the screen. So let's go back to our main method. We have already pushed one value. So next, push again. We will push again SL that push with with a value of 20, with an argument of 20, and that 20 will be accepted by our parameter int data. So we will go here in our push method, and then what? And then we will create an instance of a class stock node, then new node. Okay, then we will check if root is equal to null. If root is equal to null, okay, we will our root will be the new node. Okay, however, our root is not equal to null. Our stock is not empty because we have already pushed a value just earlier, which is 10. We already have a 10 in our stock. So we will proceed to our else. Okay, so in our else we will create a temp, which is a pointer. Our pointer will point to our root, and then our root is the pointer new node, and then the new node that next is the temp. Okay, in that way we have created a new node. Okay, and in that new node 20 is placed, right? So like this. So 20, 10, then 20 is next. It's piled up, I think. So next, then through this statement, 20 push to stock is printed on the screen. The answer is 20 push to stock is printed on the screen. Okay, let's put 20 push to stock. Okay, so there are already two elements, or there are already two nodes in our stock. Okay, 10 with a pointer, 20 with a pointer, the next. Okay, so let's go back to our main method. Now we will push again a value of 30. So we will push 30 to our stock. Okay, so our 30 will be accepted by our int data parameter, and then we will create an instance of a class stock node a new node object, then we will check if the root is empty. Wait, let's erase first. Okay, let's erase. Okay, let's check if the root is empty or the root is null. Since the root is not null because it already has two values, the 10 and 20, or two nodes, let's proceed to else. So through this block of code, we'll be able to create a new node and our 30 will be placed. Okay, so we already have 10, 20, 30. We already have 3 nodes piled up. 10, 20, 30. Okay, that's it. Like that. Okay. Okay then. So now this data, or 30, will be printed using the statement. So 30 push to stock will be printed on the screen. So now we already have 3 statements. 10 push to stock, 20 push to stock, 30 push to stock. Okay, this one. So now we will go back to our main method and we will proceed to this statement. So this statement will print SLL.pop method and the pop from stock. However, let us go first to our SLL.pop. Okay, since it is invoked, whatever is returned to our method pop, that will be the one that will be printed. So let's go first to our pop method so that we know what is popped. Okay, what value is popped. So let's erase this first. Let's erase this first so that it will confuse you. So now we will proceed to our pop here in this method, and then okay, in our variable pop we stored integer that minimum value, which is -2 to the power of 30, and then we will check if the root is null. Since the root is not equal to null, we have 3 values, we have 3 nodes rather, and the root is 30. Yes, we will not perform this. So we proceed to else, and then our root.data, which is 30, will be stored in this variable popped, and then our root, the next to root is the one that is already a root, right, which is 20. So 20 is now our root, okay, because our 30, which is our previous root, is already stored in popped. It has already been deleted and it has been returned to our method popped. So 30 has been returned to pop method. Okay, so that's it. So since it hasn't been returned, so the value of this one is 30. So this will print on screen 30 popped from stock, which is this one. Okay, so next is this. Okay, this statement. Okay, we will move on to or proceed to this statement. So this statement will print top element is. Okay, so since it has, it mentioned, or let's say it invoked or called the method pick, so we will go to pick, which is this one. Again, pick, right, will return the top value of our stock. So first we will check if the root is equal to null. Since the root is not equal to null, because our root is 20, we will not perform these operations. Rather, we will perform this one. We will proceed to else. So return root.data. So 20 will be returned. So the top element is 20. Okay, so that's it. Hello, I'm back. Okay, hello, I'm back. Wait. Okay, so let's try to run this code, the one that we discussed. Okay, implementing stock using linked list. Let's run this. Okay, so 10 push to stock, 20 push to stock, 30 push to stock, and 30 pop from stock, and also top element is 20. Okay, so what we wanted to do is I wanted to show you what I mean about when the stock, or when the root is equal, or when the stock is empty, it will return negative 2 to the power of 30. So let's delete first this one. Okay, then let's try to run this code. Right, so it printed negative 2 to the power of 30, or negative 21474836648. So that is what I meant when I said that when the stock is already empty, it will return this integer in that minimum value, integer value. Okay, so here we push to stock, then we pop to stock. So first is we pushed stock, so we have one node in our stock. However, we decided to pop our stock, okay, which is this code. We decided to pop our stock, which is our node 10. So meaning to say the top element is like our stock is empty, and the top element is negative 2 to the power of 30. So that's what I meant. So let's retrieve those. Okay, so that would be all. Okay, that would be all for our discussion about implementing stock using linked list. I hope you guys have learned a lot for today and in our video. I've enjoyed this discussion, and I hope you guys have also enjoyed. And that would be all. See you again next time. Okay, coding is fun.